In this video, you will learn about scales. Now, as I'm sure you are aware, the word scale has many different definitions. But the definition here in math that we are referring to is a ratio comparing two lengths. So if you're comparing two different lengths, that is a scale. Now, a scale drawing is a drawing with lengths that have the same ratios as the original object. For example, if a person is, let's say, 5 foot 8 inches tall, and you draw a picture of that person, that picture will not be the actual size. It will be drawn to scale, meaning if the guy is 5 foot 6 inches and your picture is, let's say, 6 inches, then the scale would be 6 inches to 5 foot 6 inches. It's a ratio comparing the two lengths, and the scale drawing will be in the same ratio for every single part of the person that you draw. So the head will have this ratio, the arms will have this ratio, etc. So where this is particularly useful is in the application of maps. And there's many other applications as well when it comes to drawing or architecture. But the examples we will use for this lesson will be dealing with maps. So on a map, the distance between two towns is 1.5 centimeters, whereas the actual distance is 30 miles. And the question is, what is the scale of the map? So remember, scale is a comparison of two lengths. So we're comparing the drawing distance and the actual distance. So the drawing distance we typically put on the top. So the drawing distance will go on the top and the actual distance will go on the bottom. All right, so the drawing distance was 1.5 centimeters. That was the distance on the map. And then the actual distance was 30 miles. So the scale would be 1.5 centimeters to 30 miles. Now, when you are dealing with scales, it is best practice to reduce the scale as best as you can. So what that means is we do not want decimals, and then once you get rid of the decimals, make sure that your fractions are reduced. So to begin with, we can get rid of this 0.5 in the numerator, and to do that, we can multiply the top and the bottom both by 10. So the top will now have 15, and the bottom will have 300. And then 15 over 300 we can reduce. We can divide the top and bottom both by 15. When I do that on the top, I'm going to have 1, and then on the bottom, 300 divided by 15 would give me 20. So the scale would be 1 centimeter over 20 miles. And then the other way we can write ratios is with a colon. So we can write this as 1 centimeter colon 20 miles. So this is the ratio or the scale of the map. Example 2. We can use the scale, once we have determined it, to then calculate maybe the actual distance or the distance that something should be on the map from each other. So for example, here the distance between two towns on a map is 2.4 centimeters. And the scale of the map is 1 centimeter to 15 kilometers. What is the actual distance between the two towns? So to set this up, I'm going to use the scale of 1 centimeter to 15 kilometers. So write it as a fraction. That scale is going to be true no matter which towns I'm looking at on the map. So on the map it says the distance between two towns is 2.4 centimeters. So here we have another fraction, 2.4 centimeters, and the question is, what is the actual distance? So the top is going to be the distance on the map, the bottom is the actual distance. So the actual distance is unknown, and that's going to be on the bottom of the second fraction. So here I have a proportion that I can solve by cross multiplying. So here you see it written over here on the side. When I cross multiply, I can ignore the units, so I can think of this as 1 over 15 equals 2.4 over x. And then I take 1 times x equals 15 times 2.4. So then 15 times 2.4 would give me 36. So my solution is that x equals 36. And what we found is the actual distance between two towns on the map. Example 3. Here is an actual map illustration with a picture, and the scale is 2 centimeters is 35 kilometers. And the question is to find the distance between little city and biggest city. So little city is right here, biggest city is here, and the distance on the map is 4.5 centimeters. So I use that number and I use the scale to determine the actual distance. So the way you set this up is you write the scale as a fraction. So we have 2 centimeters divided by 35 kilometers. That is the scale or the ratio. And then equals on the map is 4.5 centimeters. That goes on the top because the map distance went on the top over here for the other fraction. And then we're trying to find the actual distance, which would go on the bottom of the second fraction. So that is my proportion, and we see it typed up right here. When we solve this, we can ignore the units, so we just have 2 over 35 equals 4.5 over x. And then to solve, I can cross multiply. 2 times x equals 35 times 4.5. 35 times 4.5 would be 157.5. And then to get rid of this 2 with the x, I can divide both sides by 2. On the left side, the 2's cancel. I have x on the left, and then on the right, 157.5 divided by 2 would be 78.75. So the actual distance between little city and biggest city would be 78.75. The next example is working the other way. So we are told the scale of a map is 1 centimeter to 25 kilometers. And we're trying to find how far apart will two cities appear if they are actually 40 kilometers from each other. So in this case, we use the scale, which is 1 centimeter to 25 kilometers. Write that as a fraction, then set that equal to another fraction. The other fraction, we know the actual distance is 40 kilometers. So the actual distance goes on the bottom, right? The top is going to be the map distance, and the bottom is the actual distance. And then we're trying to find the map distance for the two cities. So that's your unknown, and that's going to go on the top. So you see it typed up right here with the same proportion. And when we solve this, we can ignore the units. So we can ignore centimeters and kilometers. So my proportion is 1 over 25 equals x over 40. So then to solve, I can cross multiply. 1 times 40 equals 25 times x. So 1 times 40 is 40, 25 times x is 25x. And then to solve, I can get rid of the 25 by dividing both sides by 25. On the right side, the 25's cancel. I'm left with an x over here. And then on the left side, I have 40 over 25. And when I divide those, I'm going to get 1.6. So my solution is that on the map, the cities will appear 1.6 centimeters from each other. So we stated at the beginning of the lesson that one of the major applications of scale is in maps. But this can also be for any drawing as well, and can also include it can include models as well. So for example, if you have like a model car or a model house, okay, we can use this concept of scale for those other applications as well. So we're going to throw in here one example where we look at a model. All right, so for example, Here we have a car that is 12 feet long. And the question is, how long should the model car be if the scale is 1 foot to 2 centimeters? All right, so what we can do is we can use this scale to figure out the length of the model car. All right, so we know the scale is 1 to 2. So this is feet to centimeters. So this would be for the actual. 1 foot is the actual. And then this is the 2 centimeters is for the model. All right, so for the car is in real life 12 feet long. So the actual length is 12 feet. So the question is, what is the length for the model? That is unknown, the length of the model. So we can use this ratio, or this proportion, where we have 1 over 2 equals 12 over x. We can get rid of the units as we solve. So notice in the numerator, we would have 1 times 12 gives you 12 on the top. 2 times 12 would give you 24 on the bottom. So x would equal 24, which is the length of the model car, 24, and the model the units are centimeters. So the model car should have a length of 24 centimeters. And that concludes our lesson for today. We will see you next time.